So we're on our sixth property. So the product property was number 5. So if you're keeping track, because I said there were 8 of them, same conditions. M is greater than 0, N is greater than 0, A is greater than 0, and A cannot equal 1. Then, if you're dividing in the argument, you can split them up into separate logarithms, and you're subtracting them on the left or on the right. So again, remember all of them have the same base. Base A, base A, base A. All right, so we're going to use the quotient property of logarithms to write each logarithm as a difference of logarithms, and then simplify if possible. All right, so our first one, again, I would probably put parentheses around that. So I've got division going on, and I'm going to split that up. Log base 4 of 3 minus log base 4 of 4. Now, you can't switch that around because subtraction is not commutative, so you have to make sure you subtract the part that's in the denominator. Okay, but what is log base 4 of 4? Well, that just equals 1, right? So log base 4 of 3 minus 1. Now, that's the answer. This is an exact answer. This part it represents a number. There's no variable in that part of the expression. But we'll show you later how to find out what that number is approximately. Another thing I wanted to point out is, remember property 4 that I said we're going to use a lot? You could use that here if you thought of this as 4 to the first power, and then that would just equal that exponent 1. Okay, but it's the same thing as property 2. Okay, now part B. Log of x over 1,000. Well, it doesn't have a base this time. Well, it does, but it's not written because it's a common log, so it means base 10. So you've got to remember that. So we're going to simplify it, or use the quotient property to say log of x minus log of 1,000. But 1,000 is a power of 10. And because I have a common log, I care. So 1,000 is 10 cubed. Now you can use the property 4 to say that that's just going to equal 3. So remember, property 4 says if you've got the same base to some exponent, that's just going to equal the exponent. So if the base here on the logarithm is the same as the base in the argument, it just equals the exponent. And because this is a common log, we don't write the 10, but there's a 10 right there. Okay? All right. So this was the answer.